Keeper 5.3, absolute extreme values. All right, so the first thing we want to talk about is local extrema. That's your local max and mins. So your local extrema is anywhere where the points around it are either higher or lower. So like a local max would be anywhere where all the points around it are lower than that, and a local min would be anywhere where all the points around it are higher than that point. The easiest way to find local max and local min is just to find your critical numbers, which are the numbers when you set your derivative equal to 0. It's the numbers that you find, or it could be the numbers where your derivative doesn't exist. All right, so again, to clarify those ways of finding your critical numbers or finding your local max or mins, this one is specifically for your local max. What you're going to do is use your first derivative test. That means that you're going to basically find your derivative, set it equal to 0, find the number that gives you 0, and you're going to test to see if it changes, if your derivative changes from positive to negative. If your derivative changes from positive to negative at that point, then you have a local maximum. Now, there's another way that you can test to see whether or not it's the local maximum by using what we call the second derivative test. And so if your second derivative is less than 0, that means it's concave down at that point. And if it's concave down, that means you must have a local max at that point. Now, in the same way, we're going to find we're going to learn how to find critical numbers that are local mins. So again, we're going to use our first derivative test. We're going to set that first derivative equal to 0. We're going to solve, and then we're going to check to see if that derivative changes from negative to positive. If it changes from negative to positive, then you have a local min. Or again, you can use your second derivative test, find the second derivative at that point, see if it's positive or negative. If it's greater than 0, then that means it's concave up, which means you must have a minimum at that point. So here's our example. It says find and classify all critical numbers of the function. So the very first thing I need to note is that this function is continuous. It has no jumps, no holes, no asymptotes. And not only that, it has no cusps, it has no corners, and it has no vertical tangents. So not only is it continuous, but it's also differentiable. And I needed to know that because, again, remember, your critical numbers could be where it doesn't exist, but we have no issues of a point not existing. So all I have to do is find the derivative and set it equal to 0. So first, find the derivative of f of x. That's going to be 3x squared minus 6x. Now I'm going to set that equal to 0 and solve for x. So I factored out a 3x, and then I set each one of my factors equal to 0. I get x equals 0, x equals 2. Those are the two critical points of the function. Now, to determine if the critical points are a max or a min, again, I can, number one, use a number line, or I can use a second derivative test. And I'm going to show you both of them on this example. So the first one, I'm going to put those points on a number line. I'm going to plug values in to the left and to the right of my derivative. So if I plug in a number like -1 into my derivative, I would get a positive answer. Versus if I plug in a number in this region, like the number 1, I would get 3 times 1 minus 6, which is a negative answer. And then I can plug in a number to the right of 2, which again, if I plug in like something like 3, I would get a positive answer. Now, realistically, I don't always plug in. I notice that my derivative is a quadratic function and it's positive, so it must be going up. And so I know that to the left, it must be positive. In the middle, it must be negative. And to the right, it must be positive. All right, so once I do that, I do my little arrow chart. So where it's positive, I know it's going up. And then where it's negative, I know it's going down. Well, going from positive to negative, I can see it in the chart. It creates like a maximum, like a hill. Versus if I'm decreasing, like I am to the left of 2, and then increasing, again, I can see it from the chart. It kind of makes like a valley type shape, so I know that's a min. Therefore, at x equals 0, I have a max, and at x equals 2, I have a min. Now, I could have also done that using the second derivative test. Now, I'm just going to be honest, I generally don't use the second derivative test too often, but I think it's a valuable test to know, and it's just as easy as doing the number line. So your second derivative test, you're basically going to take the second derivative of your function. So you get 6x minus 6. And what you're going to do is you're going to plug your critical values into that second derivative. So I'm going to plug in, starting with 0. Second derivative of 0 would be 6 times 0 minus 6, which is a negative 6. Since that second derivative at x equals 0 is negative, I know that it's concave down. Now, because it's concave down, that means by default, I must have a max there. And so x of 0 must be a max. And I can do the same thing for x equals 2. Again, plug it into my second derivative, so I get 6 times 2 minus 6. I get a positive number, a positive 6, which tells me at x equals 2, this thing must be concave up. Therefore, if it's concave up, all the values around it are positive or above it, so therefore I have to have a relative or local min. Therefore, at x equals 2, I have a local min. All right, so those were your local extrema. Now, this is your absolute extrema. Your absolute extrema is the very, very, very highest point or lowest point on the graph. It's your absolutely highest or lowest point. It's higher than all other points on the graph, or it's lower than all other points on the graph. And then so we have what we call the extreme value theorem, which says that if you have a continuous function on an interval, on a closed interval from A to B, then your absolute maximum is going to happen at some point between either at A and B or at those endpoints, or some number between A and B, so like C and D. Is going to happen someplace in that region. In other words, you have to have a max and a min in a closed interval. You can't have something like a jump or asymptote or anything like that, because we know it's continuous. So you must have absolute max or min. So here's the steps to find an absolute extrema. First, you want to verify that the function is continuous. The reason you want to do that is because you don't want to have an issue with any asymptotes, jumps, or holes. If you had an issue with the asymptote, especially, then your function will go off to infinity and you won't have a max or a min there. So you want to make sure it's continuous. Next, you want to find all critical numbers in that region from A to B. So you want to find your first derivative, set it equal to 0. Those will give you your critical numbers between A and B. Next, you want to find the largest y value of those critical numbers, but you also want to find the largest y value of the endpoints of the interval. And once you find those largest y values, the largest ones will be your max, and then you'll also do the same thing for the smallest, and that will be your min. So here's our example. We have find the absolute max and min of f of x equals 4x, or x to the fourth minus 2x cubed plus 3 on negative 2 to 3. So first, I need to note that f of x is continuous on negative 2 to 3. And then I want to find my derivative. So my derivative is 4x cubed minus 6x squared. Once I find that derivative, I set it equal to 0, and I factor out a 2x squared. Then I set both factors equal to 0. I get x equals 0 and 3/2. Now again, when I find my absolute max and min, I need to take into consideration those critical numbers as well as those endpoints. So my endpoints were negative 2, and 3. So I'm going to start with negative 2. I plug it into the original function. I get negative 2 to the fourth minus 2 times negative 2 cubed plus 3. I get 35. Then I'm going to plug in f of 0, which was one of my critical points. I get 3. Next, I'm going to plug in my next critical point, f of 3/2. I get 1.3125. And again, I use the calculator, but you can also do that by hand. And then lastly, I'm going to plug in my last endpoint, which was f of 3, which gives me 30. Now, out of these numbers, 35, 3, 1.3125, and 30, the largest one I have is 35. So that's my absolute max. And the lowest one I have is 1.3125. So that's my absolute min.